Assalamualaikum warahmatullahi wabarakatuh. So today we will be presenting a part of MAT210, which is proofs and argument. Let me introduce this topic. Mathematical reasoning techniques are given in the rules of mathematical logic. The origin of logical reasoning was the Greek philosopher Aristotle. The theoretical foundation for many branches of mathematics, and hence computer science, is provided by logical reasoning. It is used in the design of computing devices, artificial intelligence, and definition of data structures for programming languages, and many other practical areas of computer science. The study of reasoning techniques is the subject matter of logic. On a basic level, logic offers guidelines and methods for determining the viability of a given argument, and in this chapter we introduce the fundamentals terms and notation of formal logic and examine truth table, which offer a way to determine if a complex statement is true or false by dividing it into a group of simpler statements which true or falsity is clear. In propositional logic, generally, we use 5 connective. Firstly, we have or, secondly, and, thirdly, negation, which or not. The fourth one is implication, which is if, then, and the last one is if and only if. Proofs and argument have two methods. First one, let's talk about using truth table. An argument is valid precisely when the statement is a tautology by using the truth table. Tautology is an important class of compound proposition, consists of those that are always true, no matter what the truth values of the variables, p, q, etc. are. Such a compound propositions is called tautology. The second proofs and argument are using rules of inference or logical implication and laws of logic. In the table below, we list some useful rules of inference, logical implication, rules of inference, logical implication. First one we have addition, the second we have simplification, next we have conjunction, the fourth one we have modus ponens, the fifth one we have modus tollens, the sixth one we have syllogism disjunctive, the seventh is syllogism, the eighth is proof by cases, the ninth are contradiction, and the last one is constructive dilemmas.
Now let's move on to a description of the concept and application used. There are two methods to prove the argument whether it is valid or not, and we choose to use both method, which involves using rules of inference or logical implication and laws of logic and the truth table. Our argument is, if Enola wants to be a good detective, then she needs to solve the case. If Enola wants to solve the case, then she needs to find the evidence and arrest the culprit. Enola did not find the evidence and did not arrest the culprit. Next, I will show step by step how to prove our argument is valid. Step 1 is to declare the primitive proposition using the symbols P, Q, R, and S. We label P as detective, Q as evidence, R as culprit, and S as case. Step 2. Write the premise of the argument using those symbols. The first premise we get from argument are P implies 2S, which is that if Enola wants to be a good detective, she must solve the case. The second premise is S implies Q and R, which is that if Enola wants to solve the case, then she needs to find the evidence and arrest the culprit. The third premise is not Q and R, which is that Enola did not find the evidence and did not arrest the culprit. Last but not least, the last step is to find the conclusion of the argument using the rules of inference. We can use a syllogism to show that P implies Q and R from the first and second premise. Then, using a modus tollens, we can demonstrate that not P from the fourth and third premise. The conclusion of argument is therefore, Enola is not a good detective. From step 3, we can know that the argument is valid because we can identify the rule of inference that establishes its validity.
Now, before we explain to you how we do our solution using the truth table, let me enlighten you out with the methods or things that are inside the truth table. The first thing are negation, which is the logical operator not has the effect of reversing the truth value of any proposition to which it is applied. We can efficiently summarize the effect of logical operators using truth table. As you can see in the table, we have the variable p, which have the value of truth and false. So if we put the not p, the true value will become false and the false value will become true. Talk about conjunction and disjunction. To give the truth table for n and for or, we need to start with two propositions, say p and q. There are four possibilities for assigning pairs of truth tables, true or false. So if you see the tables on my left side, we have p and q with the value of, for p is true and false, while for q is true false and true false. If you connect those two variables p and q with n, if both of them are true, then the result will be true. But if either of them have false, then the result will be false no matter what. Next, let's talk about the table on my right side. We have the same variables and same value, but if we connect both variables with or, it doesn't matter if they have false or they have true and false in between of them. It will become true. But if both are false, they will have the result of false. So for example, if they are both true, they will be true. But if either of them is false, then they will still be true. But if both of them are false, then they will be false. And for the last one, for the truth table, we have conditional proposition, which is P implies Q. To attach a truth value to a conditional proposition, we have to draw a very careful distinction between logical truth and factual truth. The conditional implication P implies Q means that the truth of P implies the truth of Q. In other words, if P is true, then Q must be true. The only way this can fail if P is true while Q is false. The truth table, if P implies Q is, as you can see in the table, we have both variables P and Q, and then if we want to have the result of truth for P implies Q, it's either had to be both true or both false, or the first one is false and implies to true, they will become true. But if the P is true and Q is false, and when P implies to Q, it will become false. Like true implies to false, they will end up false.
Now we move to solution that we use using the truth table. Firstly, we have four variables, so the formula that we need to use to determine how row is with the formula 2 to the power of n equal to 2 to the power of 4 equal to 16. Therefore, there will be 16 rows. The first column we have variable p. For p we have true, 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 false, 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 and false. Next, for Q, the value is true, 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 false, 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 true, 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 false, 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 and false. And next, for R, we have true, true, false, false, true, true, false, false, true, true, false, false, true, true, false, and false. And for the value for s, the value is true, false, 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 true, false. For we move to the column P implies S, we have true, F, true, false, true, false, true, false, true, false, true, 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 and true. And for column Q and R, the value is true, true, false, 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 true, true, false, 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 and false. The next column is S implies in bracket Q and R. True, true, false, true, false, true, false, true, 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 false, true, false, true, false, and true.
Next, for column not bracket in Q and R, we focus on the column Q and R and reverse the value in it. From the true become false and false become true. Therefore, the value of column not Q and R will be false, false, true, 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 false, false, true, 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 and true. Next, for the column not P, we will inverse the value from the column P. Therefore, value column not P will be false, 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 true, 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 and true. Then for column hypothesis, P1 refers to column P implies to S, P2 refers to column Q and R, P3 refers to column S implies to bracket Q and R, and P4 refers to not bracket Q and R. Therefore, the value of column hypothesis will be false, 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 and false. For the last column, which is hypothesis implies to conclusion, the value will be all true. Since the last column is all true, we can conclude that this argument is valid since it's a tautology.
Summary, we have thought about logic as a separate mathematical field as well to improve our understanding and proof writing skills. Either way, we saw that mathematical statements have specific logical structure and that understanding that structure can help us understand the statement. By using logical conclusions and inference rules, we can evaluate the validity of an agreement. At its most fundamental level, a statement might use logical connectives to combine more basic claims. We often use variables and quantify them. The goal of logic is to determine whether a statement is true or false based on these connective and quantifiers. This enables us to determine whether one or more claims logically imply another, or if two statements are logically equivalent. It is our intention to clarify why a mathematical statement is true when we write proofs in any category of mathematics. It is important that our argument suggests that the claim is true. We must first understand what it means for a statement to be true to be sure that it is true. And we must also make sure that the claims that make up the proof accurately imply the conclusion. To determine whether an agreement is sound, one needs a good understanding of logic. This is our group members. We have Akila Nabila Muhammad Jaafar, Fariha Nur Azman, and lastly we have Nurul Ifa Humaira binti Azman. Inola fell asleep and had a dream that she was able to solve a case by catching the culprit and get the evidence. That she can be a good detective. But in the reality, she failed to catch the culprit and she also failed to get any evidence since the culprit ran away with it. Enola concluded that she could not solve the case since she did not catch the culprit and she also did not get any evidence. Here's come the chief fixing her statement. It is clear that Enola is not a good detective. Alright, dah rekam. Thank you.